Give the SI units of. The SI unit of distance is meter, of displacement, and that's given as m. SI unit of displacement is also same, that is meter, written as m. SI unit of velocity is meter per second. SI unit of speed also meter per second. This can be written as meter second minus 1, meter second minus 1, and acceleration meter per second square, that is meter second minus 2. Pick the scalar quantities. Now what are scalar quantities? That have only magnitude, no direction. You don't refer to direction. And what are scalar? These are vector quantities, have got both. They have got magnitude as well as direction. You need magnitude as well as direction to define them. So distance has only magnitude, and because it has got only magnitude, we call it a scalar quantity. So pick up the scalar. Distance is scalar. Displacement is vector. It has got magnitude as well as direction. Velocity is also vector. It has got magnitude as well as direction. Because of velocity, we say 4 meter per second, and we have to give the direction, maybe the north direction, or 16 meter per second south direction. That is velocity. But speed is a scalar. It has got only magnitude. If we say just 4 meter per second, it becomes a scalar quantity. There is no direction, north, south, east, west. Acceleration is a vector. It has got magnitude as well as direction. Name the quantity with unit meter per second. We've already said meter per second could be velocity, or it could be also speed. And meter per second square, and that is acceleration. Why did it come meter per second square? Because we know acceleration is change in velocity over time. It's rate of change of velocity over time, and velocity is meter per second. Time is second, so this becomes now meter per second divided by second. So meter per second, the division becomes multiplication, 1 by second. So it becomes meter per second square. That is why acceleration is meter per second square. And we know velocity is displacement over time. Displacement is meter and time is second. So velocity is meter per second. Same thing, speed. Formulas for speed is distance over time. Distance is meter, time is second, so the unit is meter per second. Now let's match the graphs with the description given on the right hand side. Now if you want to find non-uniform acceleration, and I think that would be E. This E would be non-uniform acceleration. Non-uniform retardation, not acceleration. So I just cancel this up. This is retardation. Now the first one here, A, is this first one would be uniform acceleration, body starting from rest. So this would be our A. The graph of A, it will be like velocity, time, uniform acceleration starting from rest. Now for the second one here, it would be also uniform acceleration because the velocity is increasing, but the body is not starting from rest. If you notice here, the body is starting from this point. So it would be, B would be here, uniform acceleration, body having initial velocity It is not starting from rest. It is increasing uniformly, but not starting from rest, not starting from 0. For C, if you notice, this is constant. The velocity is constant. There is no acceleration. So this would be C, no acceleration. The velocity is absolutely constant. The D would be uniform retardation. If you see in the D, there is a decrease in velocity. So that would be uniform retardation. And it would be, D would be this uniform retardation. And last, of course, was non-uniform retardation. Here, if you see, the velocity decreased, but non-uniformly. Define uniform circular motion. So it is called uniform, means it moves with a constant speed or covers equal distance in equal intervals of time. So because it's uniform, it is constant speed. And it's circular, means along a circular path. So how would you define uniform circular motion? Motion of an object along a circular path with constant speed. So we define circular motion as motion of an object with a constant speed. That is why it was uniform, constant speed along a circular path, and that's why it was circular motion. Now what remains constant in circular motion? That we have seen constant speed. So the speed remains constant. Why is uniform circular motion called accelerated motion? So when an object goes in circular motion along a circular path, it moves. The speed is constant, but its direction keeps changing at every point. So its velocity keeps changing. So it is called accelerated motion. So we can write direction changes, and because direction changes, velocity changes, and if velocity changes, it is said to be accelerated motion. Now give examples of uniform circular motion. There are many examples. We'll just give 2 of them, like the movement of the earth around the sun, revolution of the earth around the sun, the hand of a clock, movement of the moon around the earth. These are all uniform circular motions. What is negative acceleration? When there is a decrease in speed or decrease in velocity, we say the acceleration is negative. Like if a body from 10 meter per second slows down to say 2 meter per second, the acceleration will be negative. Or a body from say 50 meter per second comes to rest. Rest means stops, becomes 0 meter per second. So the acceleration is negative. And give examples when you apply brakes in a car. Apply brakes in a car. It is negative acceleration, it slows down. When a train coming into a station, it slows down. Also, a stone thrown up, the speed slows down. When you throw a stone upwards, the speed slows down, then it comes to rest, and then it comes down again. Difference between speed and velocity. So speed is distance traveled by a body in unit time. Displacement, velocity is displacement of a body per unit time. Next difference is speed is a scalar quantity, it has got only magnitude. Velocity is a vector quantity, it's got magnitude as well as direction. Speed cannot be 0. Since distance of our moving body cannot be 0, so speed also will not be equal to 0 for a moving body. However, displacement can be 0. And we know when displacement is 0, when an object goes and comes back to the same position, displacement is 0. So velocity also can be 0. So velocity can be 0 for moving body. Both have the same SI unit, meter per second. Here also meter per second. The following table represents the distance traveled by a car in a fixed direction. Calculate its speed. So to find out speed, first we must know distance and time. Now in this case, if you see the total distance it travels is 420 kilometers and in a time of 7 hours. So the speed will be distance over time, and that is 420 over 7, 60 kilometer per hour. While traveling, Javan travels 30 kilometers with a uniform speed of 40 kilometer per hour, and the next 30 kilometers with a uniform speed of 20 kilometers per hour. Find the average speed. So his journey is divided into two sections. So the first section, the distance is 30 kilometers. The speed is 40 kilometer per hour. And for the second section, he covers again a distance of 30 kilometers. But now the speed slows down to 20 kilometer per hour. We need to find its average speed. Now to find the average speed, we need two things. We need total distance and we need total time. So in the first case, the distance we know. We need to know the time. To know the time, we know the formula for time is distance over speed. That is 30 over 40. So the time 1 in this case is 3/4 hours. In the second, again, the time is distance over speed, and distance is 30, the time is 20. So the time 2 for the second part of his journey is 3/2. So his total time will be T1 plus T2, that is 3/4 plus 3/2. You take LCM is 4, then 3 per 6, that is 9/4 is his total time. And the total distance is 30 kilometers in the first section and 30 kilometers in the other. So it is 60 kilometers. This is hours. So for average speed, we have total distance over total time. Total distance is 60 over total time 9/4, that is 60 divided by 9/4 and is 60 into 4/9. You reduce it, the answer will be kilometer per hour. So remember, for average speed you have to do total distance over total time. Define uniform motion and non-uniform motion. For uniform motion, a body covers equal distance in equal intervals of time. And when it comes to non-uniform motion, a body covers unequal distances in equal intervals of time. Here, give one similarity and one dissimilarity between these two. If you look at them here, in both the cases the velocity is increasing uniformly, so there is uniform acceleration because the velocity keeps increasing in both the graphs. uniform acceleration. But there's one difference. In the first case, the initial velocity is 0, and in the next case, the initial velocity is not 0. So that's the next difference. Here, u is 0, so body starts from rest. And in this case, we see u is not 0, so body does not start from rest. Which means has initial velocity, has some initial velocity. For the sum, we need to draw the velocity time graph. So we take the velocity on the y-axis and the time on the x-axis, and I have just modified the graph. Let me go ahead and plot it. 0 time 5 velocity is 5, so that would be 0 velocity 5 would be somewhere here. Next point is time 10 velocity 10. Time 10 velocity 10 would be here. Next, time 30 velocity 20. Time 30 velocity 20. Time 30 velocity 20 would be here, right? 30 20. Then next is 40 25. So we have 40 here and 25 would be somewhere here. Then time 50 velocity 30. So this is now this is 40, this will be 50. So time 50 and velocity 30. So it would be here. And this would be the graph. Now we want to know what is the distance traveled in 50 seconds. So to find distance traveled in the 50 seconds, you have to find this area. This entire area between 0 and 50 will give you the distance traveled. So this green area will give you distance traveled. This is in 50 seconds. If you look up at this area looks like a trapezium. It is a trapezium, and hence the formula for the area is half h a plus b. Now your a will be here. This will be your a. Here will be a, which is 5. So I'll write a equal to 5. Then we have the b, the two parallel lines, and we see that the b is 30, and the height is the distance between the two parallel lines. This is the height, which is 50. This is the h, which is 50, and you go ahead and substitute. Half your h is 50, your a is 5, and b is 30. So half and 50 cancels, becomes 25 into 35. This will be a distance traveled in 50 seconds. It is a trapezium. These are the parallel lines. These two are the parallel lines. I'll just draw the trapezium again for you to understand. It's something like this, the trapezium. This is one parallel line, which we call A. This is the other parallel line, which is B. And the distance between the parallel lines here, this is our H. This is 90 degrees.